So, given slope-intercept form, y equals mx plus b, we do need to graph. That's one of the main purposes here. There's other ways to represent this data, tables, and other things. We'll talk about those more. But we got a graph. That's what's the big deal. So, m represents our slope, our rate of change, and b represents your y-intercept, your starting value. If you're looking at a word problem, you know slope is the thing that happens continuously. Like, I make this much per day, this much per hour. And slope would be, or y-intercept would be, I started off with $500. I started off with a $40 monthly fee. That's how you can figure out which one's which. So we're given the equation y equals 2x plus 3. We got to identify our slope and our y-intercept always. So we're going to do m is 2. We're always going to turn that into a fraction right away, so we have our rise over run. And we know that m is going to go up, increase, and run to the right, and our y-intercept is positive 3. Because y-intercept is positive 3, we always use that as our starting point, so that'll be my first point. And then to get my next point, I need to go up 2 units and to the right 1 unit. So up to 1 is 4, up to 5 is 2, and then over 1 would make another point. Let's say I'm not happy with, I ran out of graph up there and I want to get another point. The only time you can go left instead of to the right is when you're going backwards. So from the y-intercept, if I want to get a point on the left side of the y-axis, so over here, I would go down 2, so I do the opposite, down 1, down 2, and then to the left 1. That gets you 3 points. That gives you a better picture, I guess you could say. So then you take your straight edge, a ruler, whatever, and run your straight line through. You do need to make sure that you have arrows at the end of your straight line, because linear equations do extend on forever and ever. The domain and range is negative infinity to positive infinity. This equation, we identify our slope. It's negative 4. Turn that into a fraction, so we have rise over run. Y-intercept is 3. Plot my y-intercept first. Goes to 3. That's on the y-axis. This right here is your x-axis. You don't plot your y-intercept there. That's where you plot your x-intercepts if you had them. A negative slope means I go down first and then to the right. So I'm going to go down 4 units. So if I start at positive 3, I'll go down to negative 1 and then over 1. I could probably fit another one on here, but that's going to be stretching my graph. So right now I'm just going to use 2. I'll take my straight edge, connect point to point. If you have a ruler, you run it right through. And then you extend it, put the arrow at the end. This has a negative slope. It's decreasing from left to right, and you can see it's much steeper than our last graph. The last one we're going to do, y equals 2/3. I forgot my x. X minus 4. Slope, m, is always the constant. It could be a fraction or a decimal or a whole number next to the x. And my y-intercept is always the constant number by itself. So slope would be 2/3. That's already in rise over run form. That's a positive slope. Y-intercept is negative 4. So I plot the y-intercept first. That's my starting value, way down there on negative 4. To get my next point, I have to go up 2 units, to the right 3 units. I could do it again. Up 2 units, to the right 3 units. Now that we have enough points to make a straight line, we do that. Extend it, arrows, positive slope. It doesn't change. Later on, we'll start graphing, in point slope form, where we don't start at the y-intercept, but you still plot your first point, you still find the next points using slope. Process never changes. You guys can do this one.